So the question is something like this. I have been given a binary tree. Now if this binary tree is height balanced, then I should return true, and if it is not height balanced, then I should return false. So you should ask me, what is the meaning of height balanced? Height balanced means that for any node, literally for any node, left height and right height must not differ by more than 1 unit. So height balanced tree is that tree in which for every node, let me write every node, in which for every node, if you take the height of left tree and take the height of right tree, then the difference between those two heights will never be more than 1. So let us take an example. Let me give you a random tree. So let's say you have 3, 9, 20, 15 and 7. What do you feel? Is this tree height balanced or not? Okay, so one of you said no. Can you tell me which node is violating the height balance property over here? Which node is violating? Is this node violating? If it is violating, let's find its left height. The left height is 1 and the right height is 2. The difference is not more than 1, so it does not violate. Is that clear that this node does not violate? Does this node violate? No, because even for this node, the left height is 0, the right height is 0, the difference between them is 0, which is smaller than 1. Even for this node, the left height is 1, right height is 1, and the difference is smaller than equal to 1. For this, left 0, right 0, left 0, right 0. So none of the nodes are violating that property. So I can say that here, this particular tree is a height balanced tree. Okay. Cool. Now let me ask you another one. So let's say you have something like this. Is this a height balanced tree? This is not, right? Because let's say I'm here, the left height is 3 units, the right height is just 1 unit, and difference of 3 and 1 is 2, which is greater than 1. So what is the first approach that comes to your mind? Tell me. How many of you can solve this question? Given that we have solved previous question, can you draw some inspiration from there and solve this question on your own? Okay, so again, let me tell you one thing. So what I'll do, I'll take the actual root and I'll find the left height of the root and the right height of the root. If I see that the delta between left and right height is smaller than equals to 1, I'll return true, otherwise I'll return false. And this exercise I'll do for the actual root of the tree. Did you understand my point, what I said? That just for the actual root of the tree, I'll find the left height and the right height and I'll check the validity of this expression, whether the difference between left height and right height is smaller than equals to 1 or not. Will it work? It will not work because you have just checked for the root. At times it can happen that root is not the culprit node, but the culprit node is either in your left subtree or it is in your right subtree. So this approach might fail. So let us take an example. What could happen is that, let's say you have something like this. Is root your culprit node over here? No, because the left height is also 4 and right height is also 4. But is this tree height balanced? This tree is not height balanced. Because of which node? Many nodes, right? And one such node is I think 2. Because for 2, the left height is 3 and right height is 1. Also for 6, the left height is 3 and right height is 0. Also for 7, because the right height is 2 and left height is 0. So it's not sufficient to just check at the level of original root. You have to check it for all the nodes. So what could be the brute force approach here? Brute force approach here could be like that diameter thing only, where whenever you are at a particular node, you are first finding out the height of left, then finding out the height of right, checking if the difference is smaller than equals to 1 or not. Okay, if the difference is greater than 1, you immediately return false from there, and if the difference is, let's say, smaller than equals to 1, then you recurse on the left subtree and you recurse on the right subtree, right? But tell me one thing, can I solve this problem within height function itself? Yes, map can be used for storing the heights, and just like the last problem. But my question is that, can you solve this problem in this get height method itself? I can say yes, because all that you need to know is that for every node, you need to know its left height and right height. And you have that here. You have that in this get height method. Whenever control comes back to the node, you have your left height and you have your right height. So you can easily perform this check for all the nodes in this little function. So all that I need to do is, I need to again have a variable left height, which will store the value of height of my left subtree, and right height, which will store the height of my right subtree. And I have an answer which by default is true. And the moment I see that the absolute difference between LH and RH happens to be greater than 1, I'll convert this answer to false. And then, because it's a get height function, so I'll keep returning the height to my next parent so that my next parent can also perform this check. So return 1 plus max of LH comma RH. Pruning can be done. It can definitely be done. You can do that. So the moment you see that you have got your answer, then you can just stop calculating the heights. So tell me one thing, the brute force way to solve this question would have been like computing height at every node again and again. But here I can just utilize the get height method. That is one way. The other way is to create that height map. What is not so good about creating that height map? It requires some extra space, right? And you are able to do it without extra space as well if you use this approach. You can literally use any of them, but you have to know internally in a very, very deep manner that why should one approach be used and why not the other. Okay, now, can I do it by that pair approach? So how do I do that? Let's say this was my actual tree, which and this was my root, this was my left subtree, and this was my right subtree. So if you are returning, so what actually is happening is, if you just return a height h1 from here and a height h2 from here, you will just be able to perform h1 minus h2 smaller than equals to 1 check for this node. Now this check alone does not ensure that this entire tree is height balanced, because for this entire tree to be height balanced, this check has to be true and the left subtree has to be height balanced, as well as right subtree individually has also to be height balanced. Only if these three conditions become true at the same time, then I can say that the tree rooted at this node is overall height balanced. In simpler words, I am just trying to say that if your tree is rooted at a root, then for that entire tree to be height balanced, this left part has to be height balanced, this right part has to be height balanced, and this expression for this node has to be true. Only if these three are true, then the entire tree is height balanced. That is the only point which I am trying to make. Okay, now if you understand this point, can you implement the code to solve this problem via pairs? So I easily see that just returning height and height are not sufficient. I need to return something else also. Can somebody tell me what should that something else be? Can I return a flag, Boolean flag f1 and Boolean flag f2? Boolean flag f1 says whether this is height balanced or not, and Boolean flag f2 says whether this is height balanced or not. Now, if you have these four pieces of information here, 2 from your left child and 2 from your right child, you can return the required piece of information to your parent as well, right? So when will you say that you are height balanced or not? So for that, you just have to take AND of h1 minus h2 smaller than equals to 1, this condition, with flag 1 with flag 2. Okay, so this thing you store in a flag 3, and that flag 3 you can return to your parent saying whether you are height balanced or not. Apart from that, you are supposed to return your height as well, and that you can do very easily. So your height will be 1 plus max of h1 comma h2 again. That height also you can return to your parent. So this is the way you can keep returning these pair from bottom to top. So here again, your termination condition would be at the level of what? Would be at the level of root. So let's say I am using a pair. My first thing is a flag, and second thing is the height, which is integer, and check height balanced at a particular root. Yeah, give me the right answer for termination condition. If my root becomes null, for an empty tree, what should these two values be? True, comma 0. Yes, because an empty tree is height balanced already. So for an empty tree, I can return the flag as true. Okay. And the second thing, which is the height. What should be the height of an empty tree? That should be 0. Otherwise, what do you do? Otherwise, first you call your left child, which is your left subtree. So you call check height balance on root left, and then you call check height balance on root right, and store this value in a pair 1, store this value in a pair 2. By the time these two functions terminate, you have two values here and two values in P2. Now you can manufacture your P3 and return it to your parent. And how you can do that is, so first let's talk about the flag. So the expression for flag is known to you. So the flag depends upon the flag that you got from your left child and the flag that you got from right child. So the flag of the left child will be stored in P1 dot second. So P1 dot second and P2 dot second, and this condition should be true. And what is this condition? It is that absolute value of P1 dot first minus P2 dot first, it should be smaller than equals to 1. This should be your third condition. Yeah, this way you have manufactured your termination condition. Sorry, not termination condition, your flag, right? Now once you have manufactured your flag, you can manufacture your height also. So your height will be 1 plus max of the two heights. So first height is in P1 dot first, and second height is in P2 dot first. And now you can return the pair flag comma height, right? So this way you can go on, and let's say your driver function had called for actual root, so whatever would be that pair dot first, that would be the answer for overall tree.